Welcome back to Stewart Science. We've been talking a lot about how to gather data, how to design experiments. Today we're going to be talking about what we do with all that data when we get it. When we have our 8 samples taken 3 times and averaged, then what? So we talked about how to create a graph, how to construct a graph. Today we're going to be looking at how to analyze a graph, how to put a line on our graph and then use that to find a relationship. Specifically, what we're talking about today is how do we find slope? Because the slope is going to give us the numerical connection between our x variable and our y variable. The slope is the relationship that you can put numbers to that allows us to use one variable to make number predictions for the other variable. So I'll give you some sample data here. This data should look a lot like what your data would look like. If you look at the time column, that goes up by 5 because we have control over that. That's our manipulated variable, and that's why it's on the x-axis across the bottom. We go in regular intervals because that's easy for us to set 5, 10, 15, 20 minutes. If we're in control of it, that makes sense. Now, the harder thing is the temperature numbers, because those aren't as nice and pretty because it's our responding variable. It's the measurements that we're taking, which is why it's on the y-axis. So the next question we got to ask is, how do we graph this? And so I gave you a rule in a previous video. Make sure on your axis your numbers go by regular numbers. So the x-axis is pretty easy because that's what our numbers go by. I made it go by 5s. 5, 10, 15, 20, 25, 30, 35, 40, yada, yada, yada. You get the idea. Now the y-axis, we had some choices to make because if we went every box is 5 up that axis, we run out of room really fast. So not all of our numbers would fit on this screen. If we go by 50s, all of our whole graph fits into like the tiniest little corner of our screen, and that doesn't help us either. So we have to kind of balance this. Again, it's really important that we keep it consistent. If I start at 0, then I go to 20, every box after that goes up by 20, which is why when you look at my scale on the side, you see 20, 40, 60, 80, 100. I want to reiterate, I see this mistake all the time. Don't look at your numbers here and then just throw them on your graph. We have to be consistent. So again, if I went by 5s, I'd run out of room. If I went by 50s, it fit in a postage stamp. So I went by 20s because it's nice and easy to get all of our numbers there. At that point, now that your scale is set, just plot your points like an x comma y coordinate. Time is our x value, temperature is our y. So our first point is going to be 0, 20. Over 0, up 20, that's where our first dot goes. Our second point is going to be 5, over 5, up to 33, and you put a point there. And again, this is going to be perfect because we're using paper and pencil. I plotted my points there for you. Doesn't look great, but you know, we're using paper and pencil. At this point, do not connect your dots. I've said this in another video. Use a line of best fit. Put a ruler down on your paper and draw a straight line through this as best as you can. That's what I did there. So this is called the line of best fit. At that point, now that you have your line, forget all your points. The line is all you care about. So I just picked 2 points that went through easy points. You can pick any 2 as long as they're kind of far apart. If you pick 2 numbers that are close together, there's not enough difference in your x and y to get a good reading. So I picked 2 numbers that are kind of far apart on your line. I picked 20, 80 as my first one, and 40, 140. So the bottom point is 20, 80. The top point is 40, 140. And again, I picked 2 numbers on my line. Doesn't matter where you pick them. Just make sure they're kind of far apart. The next thing you got to figure out is what the y values are and what the x values are at those points. And so in your math class, hopefully you've learned that slope is y2 minus y1 over x2 minus x1. That's a fancy math equation way of saying it. I say it's rise over run. Easier to remember that way. So the rise is the change on our y-axis. You can see our first number here started at 80 and it went up to 140. So that's 140 minus 80. It's our second y number minus our first y number. That's our rise. Then we find our change in our x, which is our second x number minus our first x number. Our second x is 40. Our first x is 20. As if I'm doing rise over run, I have that number that you see on the screen there, 140 minus 80. That's how far it rose. 40 minus 20, that's how far it ran. It went from 80 up to 140, so that's our change in our y. And it went from 20 to 40 minutes. That's our change in our x. When we do those numbers, we get 60 for our rise and 20 for our run. So we have 60 over 20, and a little bit of easy mental math would tell us that that is 3. So our answer is 3. If you give me that on a quiz, though, you're going to get that wrong, because like we said before, every single time you write a number, I want to see a unit. So it's 3 watts. The unit is a hard question. We need to go back to our graph. What's on our rise axis? What unit is that? Well, it's Celsius. What unit is on our run axis? It's minutes. So we're going to have Celsius over minute, or degrees Celsius per minute. What this statement means is that every 1 minute, our temperature rises 3 degrees. Every one we run, it rises 3. Every 1 minute is 3 degrees Celsius. So that's our answer, 3 degrees Celsius per minute. And what that means is every 1 minute, our temperature increases 3 degrees. This is Mr. Stewart. As always, keep learning no matter what.